Welcome to our review on the Group 1 elements. First thing we need to know about the Group 1 elements is the name of the group, which is the Alkali Metals. So we find Group 1 on the far left-hand side of the periodic table there, as you can see highlighted in red. Because we've got all of these elements within the same group, then they're all going to react in a similar way. And one of these things that they're going to do is they're actually very reactive with air and water. So what we have to do is when we've got those metals, we've got to store them in oil in order to prevent them from reacting with the oxygen and the moisture in the air. So whenever you've seen these in class, then they come in these little bottles floating around in this weird liquid, and that's oil to stop them reacting with the oxygen and moisture that's present within the air. So if we consider the properties of our alkali metals then, first of all, they're shiny when freshly cut, and hopefully you saw that in a demonstration in class. They're also good electrical conductors, and they're solid at room temperature, but what you find is that they're actually soft enough to be able to be cut with just a scalpel or a knife. And hopefully again you saw that demonstrated in class for you. Now the demonstration you should have seen is where your teacher would have taken a little bit of lithium, a little bit of sodium and a little bit of potassium, and then dropped it into a big bowl of water, probably with universal indicator in it. So what you should have seen in that is that lithium will fizz around a little bit slowly on the surface and be quite dull as a reaction. In all honesty, it doesn't do a whole lot, it just fizzes and moves really slowly. When we then came to sodium, then as soon as it touches the surface, it turns into a molten ball and then it zips around on the surface quite quickly. And then potassium, as soon as that touches the surface of the water, it bursts into flame and burns with this lilac flame, and then it's zipping around on the surface really quickly, and it can also explode. So what we can see from those results is that as we go down the group, the reactivity increases. When you saw the reaction, hopefully you then went on to write both word and balance symbol equations for this. So at the top I've given you the general word equation, which is metal plus water makes metal hydroxide plus hydrogen. The only thing you need to do to make it specific to any given alkali metal is change the word metal for whichever metal it was. So if it was lithium, we'd write lithium plus water makes lithium hydroxide plus hydrogen. If it had been sodium, sodium plus water makes sodium hydroxide plus hydrogen. For the balance symbol equation, again, the top one I've given you is a general version. So we're using M to represent the metal there. So two metals react with two molecules of water to make two of the metal hydroxides and hydrogen. So we write that as, if we look at lithium again, 2 Li plus 2 H2O makes 2 LiOH plus H2. And the really good news for those of you who really hate balancing and probably gave out that audible groan when you saw a balance symbol equation, when we're talking about the alkali metals and water, you can just learn that 2's go in front of everything except the hydrogen. And that means whatever alkali metal they've given you to react with water, it will always be 2 of the metal, 2 water, and 2 of the metal hydroxide. And just remember that hydrogen goes around as a diatomic molecule, so it's written as H2. Now, obviously in the experiment there, we made a gas because that's what's causing all the fizzing around the surface of the metal and making it zip around on the surface. And in our equation, we've said it's hydrogen, but as always in science, we need to be able to test this and prove it. So the gas test you need to remember to prove that the gas is hydrogen is that you collect it in a tube, and then when you place a lit split inside, it makes a squeaky pop sound. Hopefully you remember from our work on electronic structures and the periodic table that all of the group 1 elements will have one electron in their outer shell. And because they've got one electron in their outer shell, that means that they all react in a similar way. Hence why when we put them in water, they all do a similar thing, just it gets a little bit more exciting the further down the group you go. The reason that they're all going to react in this similar way is that that one outer shell electron is going to be lost there, and it will make a single positive ion. and then that's going to react with the other chemicals that are present. What we find is that the reason that the reactivity increases the further down the group you go is because the easier it is to lose the electron from its outer shell, the more reactive it is. And as you go down group 1, then we're getting more shells before you get to the outer shell. And the further from the nucleus that outer shell electron is, the weaker the force of attraction that's holding it in place. So it gets lost easier. The last thing we need to consider here is the ionic equation. Now there's a phrase at the top there that's going to help you out wherever we're looking at any of these ionic equations, which is oil rig. Now oil rig just stands for oxidation is the loss of electrons, reduction is the gain of electrons. Now what we're actually seeing in group 1, as we've said, is that an electron is being lost from the outer shell. So if we're losing electrons, it will be an oxidation reaction. So if we come to write a general ionic equation first of all, we're using M again for the name of the metal. So our metal atom, M, makes the metal ion, M+, and an electron, which has the symbol E-. If we then look at that with the example of lithium that we've been using, we'd start off with lithium as Li, and that would make Li+ and 1 electron, E-. So it doesn't matter which metal you've got from the alkali metals, all you need to do is change the M to the symbol for that particular alkali metal. Hopefully at the end of this video you can recall what the group 1 metals are actually called. You can describe how they react when placed in water and how they're stored, and you could also go on to predict how the alkali metals found beneath the ones that you've studied would react as well. You should also be able to write both word equations, balance symbol equations and ionic equations and explain why they all react in a similar way.